So picture this, you're in a major city and are looking for a parking spot. We can all agree that it takes a while. Recently, it has become difficult finding dedicated parking spots, especially in major cities. This leads to a lot of drivers encroaching upon private property and trespassing into parking spots meant for the users of a particular facility. For example, this happens a lot with offices or educational institutions. This leads to inconvenience for the users who actually need to use the facility. They in turn have to go look for other places to park in, and there is no system that is there to keep track of the parking spots, and there is no safety guaranteed once the car is parked.
To solve this issue, we have come up with a smart parking system. The user's entry and exit from the parking lot is tracked as a user ID along with their time of entry and exit. This is done using RF transmitters as an onboard unit and RF receivers at the entry and exit point. The data is then stored on a database for safe storage. Based on the duration of parking, a bill is generated and stored in the user's account. This system thus manages the entries into the parking lot and prevents the entry of unauthorized users into the parking lot, considering that they do not have a user ID. New users can be added to the authorized users list, and the rate of parking can be changed during peak hours if required.
We'll now be looking at the hardware utilized for our project. The first part is the NodeMCU ESP8266. We then have the generic E14012 transmitter and the receiver. We then have a breadboard where our node MCU and transmitter receiver modules are connected. For the connections themselves, we'll be using male-to-male jumper wires.
We will now assemble the receiver unit, which will be used as the parking gateway. We place the node MCU onto the breadboard. We place jumper wires at D2, D3 and V in. We then plug the receiver module onto the breadboard. The D7 of the node MCU is connected to D1 of the receiver. D8 is connected to the D2 of the receiver. Finally, V in is connected to the VCC of the receiver. The ground of node MCU is connected to the ground of the receiver.
We will now assemble the parts for the transmitter unit that will go onto the cars. We first plug in our node MCU to the breadboard. Then we place our jumper wires at D3, D2 and at VIN respectively. We then insert the transmitter onto the breadboard. We connect the D3 of the node MCU to the D1 of the transmitter, and then we connect the ground of the node MCU to the ground of the transmitter, and then we finally connect the VIN of the node MCU to the VCC of the transmitter.
Now that the assembly of both the units is done, we power them using a USB cable.
Now let us see the live demonstration of the project. So when we supply power to the node MCU, it automatically connects to the local Wi-Fi connection and creates a DNS server with a configured localhost website. This will be displayed in the serial monitor. Now we run the Python script. The Python script scrapes the data from the localhost, which was created by the Arduino. The main functionality of the script is to scrape data from the private site and handle the inputs.
Okay, so now let's try the empty spaces. In the event of a wrong reception POF UUID or blank reception, which will be basically an empty data input, the Python script handles such test case events as well. The script translates the received bits into strings and checks the database if the user really exists. If it does not, it simply prints user does not exist in the system.
We will now simulate the entry of a first user whose unique identification number is UUID123456, which will be sent from the onboard unit in the car to the receiver at the parking lot. As stated before, the received UUID is processed by the script as a string input and query to the database. Here the user exists in the database and hence is logged into the park document, which holds the records to all the vehicles currently parked. The system displays the message with the user's name and the time of his entry and also stores the same.
Okay, so now we'll be simulating a scenario of a jam in the entrance of the parking lot. This is where the receiver catches on to multiple transmissions from the same car's OBU. In such an event, using the time of entry, the script ignores multiple entries up to 5 minutes of the same car from being made. This is essential to make the transaction of OBU and the system to be hassle-free. We require the transmitter to always emit the radio frequency as it is a low power consuming device, thus making it more efficient.
Now let us enter another registered users who will be logged in successfully in the park document. Let us also simulate another jam at the entrance of the parking lot where the receiver will receive multiple inputs from the OBU.
If an unregistered user tries to enter the parking lot, his entry will be flagged by the system, and even if it receives a corrupted or faulty entry, it will also be flagged as an error and will not be logged into the database. Here you can see that we have tried 4 different types of UUIDs and all of them are replying with the user does not exist, hence not putting it in the database.
Now let us simulate the exit of a registered parked user with the UUID 123456. The receiver again picks up the same signal it had already received at the entry gate of the parking lot. As the user is already logged into the park document, the script queries it and removes it from the document and adds it to another document named history, which contains the records of the past user parking containing the user's entry time, exit time, his unique ID and the current bill for the entry and exit. Let us now simulate the exit of another UUID 654321 user. Let us focus on the bill calculation. The calculation of the bill is done by calculating the difference between the entry time and exit time of the vehicle. The user is then charged on the basis of the duration of stay and is charged differently for longer stays. For the first 7 hours, the user is charged 10 rupees per hour. The following 7 hours, that is 8 to the 14th hour, the user gets charged 9 rupees per hour. And any hour spent in the parking after this, the user is charged at a rate of 8 rupees per hour. The calculation function is mentioned explicitly in the terms of duration stay for ease of customize in billing so that different places can customize how much they would charge for the different segments or perhaps even create new segments.
Now we can see the database, how the database actually looks and the structure of it. So we have basically 3 main tables, which will be history, parked and users. Here the park table is not visible because in this instance there are no vehicles that are currently parked. In the users table, we keep track of what the users information are. So like the company names, email IDs, their names, their phone numbers, the bill that they have gotten till now, what their UUID is, what their vehicle number is, and what type of vehicle they have. This is all required to for the admin so that they can see what the user is and all the details about them. So other than that, we also have the history table. In the history table, we keep data like the enter time and exit time, the total park bill for that session of parking, and the UID associated with the parking. So this is just to keep track of how the functionality of the parking lot has been used. In the parked table, we'd have 3 fields. That is the UID to get to know which user is using it, the enter time, which would be in milliseconds, the epoch time of the system basically. This would be used for calculating the bill, and we'd also have a time that would be a standard date time format, so that it's easy for the admins to see when the user was using the services.